The largest airborne observatory in the world, SOFIA, has sadly left us. Join me as we look at this telescope mounted on top of a Boeing 747 jet, which flies into the skies to observe infrared signals that are usually blocked by our atmosphere. We lines also see how it detected water on a faraway planet and then revealed what stars are made of. This is a telescope with a 2.5-meter primary mirror, a 17-ton instrument that was literally placed on top of a Boeing 747 aircraft. This plane flies above the clouds so that its telescope can observe infrared light that would otherwise be blocked by our atmosphere. And because the telescope is mounted on a real airplane, it can fly to different latitudes and longitudes to track targets of interest. This makes it more flexible than ground-based telescopes and allows it to observe targets for longer periods without having to worry about the stars appearing to move due to the Earth's rotation. In fact, this telescope was originally designed to observe the infrared light released by the dust in our universe. Infrared light is electromagnetic radiation with wavelengths longer than visible light but shorter than radio waves. Much like how rainbows are created when sunlight is split up by a prism into different colors based on wavelength, the universe emits a spectrum of light. We can use this spectrum to understand the properties of celestial objects and use it to learn about our universe. However, the Earth's atmosphere absorbs most of the infrared light that passes through it, blocking our view of the universe in this wavelength. SOFIA was therefore designed to bypass this problem by taking the telescope to the sky. The telescope was built in the late 1990s and early 2000s and was an international project involving NASA and the Deutsches Zentrum für Luft- und Raumfahrt, or DLR, which is the German Aerospace Center. The telescope first flew in 2004 and continued to operate until 2022. In that time, it revolutionized our understanding of the universe and made many groundbreaking discoveries. One of its first major discoveries was the detection of water on a very distant world orbiting a red dwarf star named Gliese 581. This discovery was made in 2009 when the telescope observed the star system in the constellation of Libra after finding strong evidence of water vapor in the planet's atmosphere. Scientists were excited to learn more about this exoplanet and its potential for hosting life. Water is considered a key ingredient for life as we know it, and the discovery of water on this planet raised hopes that it could be habitable. Follow-up observations have since confirmed the presence of water on the planet and have helped scientists to study its climate and weather patterns. But this wasn't the only exoplanet that SOFIA studied. It also observed WASP-39b, an extremely hot gas giant around 700 light-years away from Earth. WASP-39b has a very tight orbit around its star and is incredibly hot with temperatures reaching over 1100 degrees Celsius. SOFIA detected water vapor in its atmosphere, indicating that there could be a liquid ocean beneath the clouds. Further observations of WASP-39b have revealed other interesting features such as strong winds and a possible magnetic field. However, observing planets isn't easy. They are very small compared to stars and often very far away. As a result, they are difficult to observe and study. But thanks to its unique capabilities, SOFIA was able to make some incredible discoveries about these faraway worlds and their atmospheres. The reason why it was able to detect water in the first place is because of a technique called spectroscopy. Spectroscopy is the study of the interaction between matter and electromagnetic radiation. By analyzing the spectrum of light that passes through or is reflected by an object, scientists can learn about the object's chemical composition, temperature, density, and other physical properties. In the case of the exoplanets, SOFIA used spectroscopy to analyze the light that passed through their atmospheres. By studying the spectrum of light, scientists were able to identify the presence of water vapor and other molecules, providing valuable insights into the planet's atmospheres and their potential habitability. SOFIA also used spectroscopy to study the chemical composition of stars, nebulae, and other celestial objects. For example, by analyzing the light from stars, scientists can determine their temperature, luminosity, and chemical composition. SOFIA's high-resolution spectrometer was able to detect the presence of lithium in the atmosphere of a white dwarf, which was surprising as lithium is not normally found in stars. This discovery provided new insights into the life cycle of stars and the processes that occur at the end of their lives. It also used this technique to study Sagittarius B2, a massive star-forming region located in the center of the Milky Way. This region is home to hundreds of young stars and is one of the most active star-forming regions in the galaxy. SOFIA's observations reveal the complex interplay of chemistry and dynamics in this region, providing valuable insights into the processes that drive star formation. And finally, one of the most exciting discoveries made by SOFIA was the detection of carbon monoxide in a quasar. A quasar is a bright and distant active galactic nucleus that is powered by a supermassive black hole at the center of a galaxy. The carbon monoxide was detected in the quasar S-host galaxy and provided evidence for the presence of cold gas in the galaxy S nucleus. This discovery was surprising as quasars are thought to have very hot and tenuous gas in their nuclei, and it suggested that there may be more structure in quasars than previously thought. So as you can see, this telescope has made some truly remarkable discoveries. But sadly, after 18 years in the sky, SOFIA has landed back on the ground for the last time. Its final flight was in September 2022 when it observed a supernova in the M82 galaxy. The telescope was then retired in December of the same year. There are a number of factors that contributed to the retirement of this telescope. One of the main reasons was the high cost of operation. The annual operating budget for SOFIA was around $25 million, and the costs associated with maintaining the telescope and the 747 aircraft were becoming increasingly prohibitive. Another factor was the aging of the telescope. SOFIA was first launched in 2004, and the telescope's instruments and components had begun to show signs of wear and tear. This made it more difficult to maintain the telescope's performance and increased the risk of technical problems. Additionally, the retirement of the 747-7 aircraft, which was the only type of aircraft that could support the telescope, also played a role in the decision to retire SOFIA. Despite its retirement, the legacy of SOFIA will live on. The data that it collected during its lifetime will continue to be analyzed and used to make new discoveries about the universe. And the knowledge and experience gained from operating SOFIA will be used to develop future space-based observatories. So while SOFIA may have left us, its contributions to our understanding of the universe will continue to inspire and amaze us for years to come. I hope you enjoyed this video. If you did, please hit the like button and subscribe so you never miss out on any of our future videos. Thanks for watching.